Hello, today I want to show you how to size a pond pump. And when I'm sizing a pond pump, I like to draw a little picture so that I keep everything in perspective. There we go. Got my pen working. This is going to be my pond. I'm going to put the pump over here. It's a beautiful pump, right? And I'm going to draw. This is going to be a pipe that goes across, out the side, up from the ground, and it's going to feed into a fountain. No, not a fountain, a waterfall. Okay, so now my waterfall is going to have a rectangular shape. It's really going to be flat, not like I'm drawing it here. Flat rectangular shape. It's going to be 2 feet wide, and get all my other measurements in here. This pipe right here is going to be 20 feet long. This pipe is going to be 7 feet tall. Okay, so that's going to be 7 feet long. And I'm going to change the blue so that you can identify the water here. This is going to be the water level, and inside the weir, this is my waterfall. Inside the waterfall weir, I'm also going to have a water level there. All right, a couple more measurements here. Let's do this right here. Let's do this in red. I'm going to have 3 feet of pipe above the water level, okay? And I specify that because that's my head. So 3 feet of pipe above the water level, but 7 feet total pipe coming up, 20-foot horizontal run. Now, in order to size a pump, or properly choose a pump, I have to have 2 bits of information. I have to have the flow, and I have to have something called the total dynamic head, which sounds really fancy, but it is just the friction loss in the pipe converted to vertical feet, in addition to the actual vertical feet that I'm pumping up above the water level. So let's start off with my waterfall. I'm going to get a weir calculator, and I'm going to identify the flow, because I can't get a total dynamic head without first having the flow. So I'm going to use this weir calculator to identify the flow, and there's one I use online quite often. So let me get rid of that right there. Let me show you how this works. All right, so the length of the waterfall, or the weir, is going to be 2 feet. The height of the water level, and it's showing you this right here, height of that water level is going to be in inches, and it's going to be 3/4 of an inch, so I'm putting in 0.75. I want my answers to be in gallons per minute, and immediately this wonderful weir calculator gives me 48 gallons a minute. So immediately I can go back to my chart, and I can, let me write this in here, 40, oh boy, that's awful, 48 gallons a minute, right? That's half the battle right there. Now I just have to use 48 gallons a minute as my flow rate to find my friction loss. Now, I'm going to quickly add up the length of pipe, which is 20 feet plus 7 feet. So it's a total of 27 feet. I don't mind writing that out here in the middle of everything. And that is 27 feet length of pipe. It's not head. Sometimes people get confused, make that head. It's not head. That is just length of pipe. Okay, now of course, I've got to convert that to a vertical lift. So I'm going to use this little giant chart they have in their wastewater catalog, which works wonderful. If I go down to 45, okay, so this gives me friction loss in 100 feet of pipe. And over here on the left side, it gives me the flow rate. I've got 45 gallons a minute right here, but it's not 48. So I'm going to go ahead and round up to 50. And rounding up on a pond pump is actually good, because if you keep rounding up, you get maybe 10 or 20% bigger. You put a ball valve in there, slow it down, no problem. You're taking a pump that's could work at 100%, and you're turning it down. You're letting it work at 80%. Pumps like that, so that's perfectly fine. So we're going to take that 50 gallons a minute, follow it over here to the 2-inch pipe, because we're going to use 2-inch. Now we could go with a 3-inch pipe, and you can see the friction loss over here to 3-inch pipe. But I'm going to go ahead and go with a 2-inch pipe, because it's not very long. That friction loss really isn't going to add up. Even just to make the math easier, I do this all the time. Just to make the math easier, it says 4.67. I'm rounding that up to 5. And I'm doing that because, A, I've got elbows. Okay, so if we look over here, this is my pipe fitting friction loss. So 2-inch pipe, I'm going to have two 90-degree elbows, and that's going to be, what, 11 feet of head? Round it up a little bit again. It's not 11 feet of head. I almost said that wrong. It's 11 feet of pipe length. Okay, so I've got 11 feet. Remember, I had 27 earlier. So now I've got 38. And again, make the math a little bit easier. If I had 100 feet of pipe, then what would be 40%? Because I'm rounding up and saying I got 40 feet of pipe. I should actually write all that down. Let's do that. I'm confusing people. All right, so I came up with 11 feet of friction loss from my two 90-degree elbows. Okay, so now I have added that to, that's an 8, making my 8 wrong, and a 3, so that's 38 feet. Now, I did round up to 40 because I like doing math in my head, but the math I was doing in my head all comes from this right here, which is a friction loss. But right here, go back to 50 gallons a minute, over to 2-inch pipe. That's 100 feet, but I've only got 40 feet, so I rounded up to 5. What's 40% of 5? It's 2, right? It's just 2. So I even round up a little bit. It just doesn't add up to a whole lot, but we're going to have to add it in. So I've got 2 feet from friction loss. I'm going to write that out. Friction loss. And over here, I've got 3 feet because this is the top of the water level. And I'm pumping up that 3 feet length of pipe. So that is 3 feet. So I'm going to add my friction loss, which is 2 feet, plus my vertical lift, which is 3 feet. And I get 5 feet. Okay. So now I'll go up here and put that 5 feet in as my total dynamic head. So when I'm looking for a pump, I'm looking for a pump that'll pump 48 gallons a minute at 5 feet of head. Okay. So I'm going to go back and draw my website over here. I can pull up my F-Series water pump. And luckily, they've got a chart here. And under the chart, it gives me 0 feet ahead, 1 feet ahead, and 5 feet ahead. And all I have to do is go down my list until I find a pump that'll give me 48 gallons a minute at 5 feet ahead. Now, right here, this one does 2,900 gallons an hour. 3,000 gallons an hour would be exactly 50 gallons a minute. Okay, so maybe I'm a little shy here. Maybe I go with it anyway because it's really, really close. But I will probably bump up to the next size up because I'm greedy. I want to have more, and I'll probably turn it down, with a ball valve so that I can, so I have more control over the flow. I can always get a bigger pump and go turn it down, go less. So that is how I find or size a water pump for my pond. And I hope it was easy to follow. Thank you.